Our next topic is pH and pOH. You're probably somewhat familiar with pH. You've probably heard of it before, like the pH scale or pH balanced. pOH might be something that's new to you. But you maybe don't know, and even if you know how to calculate them, you might not know exactly what those numbers represent. So first we're going to talk about why pH calculations or pH scale even exists. We use pH simply because the H3O plus concentrations for aqueous solutions, and therefore also the OH minus concentrations of aqueous solutions, are very small numbers. We looked at quite a few, we did quite a few H3O plus and OH minus calculations in the last video. And so if you look back in your notes, you'll see that these are really small numbers, 10 to the minus 7, 10 to the minus 10, 10 to the minus 5. So they're all very small numbers. And they're cumbersome to write because you have to write them in scientific notation. They're kind of big. So instead of expressing H3O plus and OH minus as their molarities, we instead express them as pH. Or we can express them as pOH. So let's take a look at how we convert and express H3O plus as pH. The equation that we use to do that conversion is pH is equal to the negative log of the H3O plus concentration. And let's talk about what all those things do. So the H3O plus concentration, as you know, is the molarity of the H3O plus. The log is just the mathematical log function like you have on your calculator. And all the log does is change the value of the H3O plus concentration. In general, I'm not a math person, but in general what this is doing, the log function, is that it makes the number bigger. In this case, the number that we're making bigger is the molarity of the H3O plus. It just makes it into a bigger number. In the numbers that we're dealing with, the molarities of H3O plus, they are typically numbers with negative exponents, like 10 to the negative 7 or 10 to the negative 2 or 10 to the negative 5. When you take the log of 10 to the negative 5 or 10 to the negative anything, the result, the answer, ends up being a negative number. So we have built this negative sign into the equation to make the number positive. And so this is how we calculate pH. pH is just a direct reflection of the H3O plus concentration in the solution. pOH, which you might not have heard of before, is pretty much the exact same thing, but here we're using the OH minus concentration instead of H3O plus. So the pOH is the negative log of OH minus. So last time, one of the things that we talked about was the definition of neutral solution, acidic solution, and basic solutions. And we were defining neutral versus acidic or basic based on the H3O plus concentrations. So if you look back in your notes to the last section, you'll see that we said when we have a neutral solution, the H3O plus concentration is equal to the OH minus concentration, and they are both equal to 1 times 10 to the minus 7. And we also said, leave a little bit of room, leave a line. We also said for an acidic solution, the H3O plus concentration was greater than the OH minus concentration. And we didn't say this next thing, but the H3O plus concentration is also greater than 1 times 10 to the minus 7. So let's think about why we know that. We know if the solution is neutral, H3O plus and OH minus are going to be equal to each other 1 times 10 to the minus 7. If H3O plus goes up and OH minus goes down, H3O plus is going to be going up from 1 times 10 to the minus 7. It's going to be getting bigger than 1 times 10 to the minus 7. So that's how we know that. And then we also said yesterday, for a basic solution, in this type of solution, the H3O plus concentration was less than the OH minus concentration. And we can also say the H3O plus concentration is less than 1 times 10 to the minus 7, because in a basic solution, H3O plus has gone down from 1 times 10 to the minus 7. So let's do some pH calculations with these numbers. For a neutral solution, we know right away, if we wanted to calculate the pH of a neutral solution, we would use pH equals negative log H3O plus, and we know the H3O plus for this neutral solution, so we can plug that in. Negative log of 1 times 10 to the minus 7, the H3O plus concentration. Stick those numbers into your calculator and you're going to get 7. So we know that for a neutral solution, the pH is always going to be equal to 7. Let's do the same type of thing for an acidic solution. If we wanted to calculate the pH of an acidic solution, again, we're going to use negative log of H3O plus, but we need to pick an H3O plus concentration that meets the criteria for being acidic. We need something that is greater than 1 times 10 to the minus 7. Let's just say, such as H3O plus equals 1 times 10 to the minus 5, because that works. That meets the criteria. It's greater than 1 times 10 to the minus 7. So let's use that for this calculation. pH equals the negative log of H3O plus, the negative log of 1 times 10 to the minus 5. Put that in your calculator, you're going to get 5. Let's do this again for the basic solution. If we want to calculate the pH for a basic solution, pH equals negative log of H3O plus. And let's think about what would be a reasonable H3O plus for a basic solution. Let's come up with something. In order for this solution to be basic, H3O plus has to be less than 1 times 10 to the minus 7. It has to be small. So let's say 1 times 10 to the minus 10. pH is negative log of H3O plus, negative log in this example of 1 times 10 to the minus 10. That's going to give us a pH of 10. So we can see some trends here. We can see if when the solution is neutral, we said the pH is 7. When the solution is acidic, we got a pH of 5. And when the solution was basic, we got a pH of 10. We can generalize that and say for a neutral solution, the pH is always going to be exactly equal to 7. Not 6.9, not 7.2, it's just exactly 7. When we have an acidic solution, the pH is going to be any number less than 7. Any number. It could even be a negative number, even below 0. There's no limit to how low pH can go. And when we have a basic solution, we can say that the pH is greater than 7. Some of you may have seen a pH scale that stops at 14. That's not a rule. You could have a pH that's even greater than 14.